to deal especially with biomechanical simulations. Mostly regarding the modelization and finite element analysis of bone structures. For example, we're going to open the folder that we are working with today. Yes. This file is of type OBJ, a 3D object file. We can open it, why not, directly in Windows. This is how it looks like. It's worth to note that the OBJ file can originate from a 3D software like Maya, 3D Studio Max, Blender, Cinema 4D, and similar others, or from computer tomograph slices, which then use OBJ as an intermediate file, as an export. Today we are going to take this geometry and edit it, customize it for finite element analysis, obtaining in the end these bodies as solid bodies, because right now they are shell bodies, and I will show this to you. Alright, so let me open Space Claim for the moment. If you didn't do it until now, we advise you to use the 3D modeling software that is a part of ANSYS product suite called Space Claim. So from the file where from the folder where the file was, we will just drag it in our Space Claim window. Let's minimize this. And we have an overview of what we are going to deal and edit for today. Firstly, let's make a section in order to ensure or to prove to you that this model is a shell body, which means that it is hollow on the inside. We're going to use a face which is somehow in the middle for the moment. Let's expand a little, and we will click the plane icon, which will use that face, the clicked face, as in order to build a plane. You can see the triad here, a coordinate system, which will help in kind of move and reorient the plane that was just created. We need nothing very exact, it's just a proof that this body is hollow, okay? Let's select the plane, you can see it here in the model tree, and we're going to press the section mode button. When we look inside, yes, you can see that it is hollow. The jaw, the lower part is hollow, also the rest of the skull and the teeth are hollow and somehow collide, are embedded in the jaw as it should be. You are going to ask how we know that it's hollow. It does not have a hatch. Okay? When it has a hatch, you know, an inclined section, yes, to show that it is a solid, we can be sure that the 3D model is usable for meshing further in our steps. Let's prove for a second the hatch that I mentioned about. The OBJ file that we just imported, initially we can see it here as something called Faceted. Yes, let's drag and drop it on the upmost, on the top, let's say on the root. We can just delete the original, let's say, folder, and we clearly have such a model. But in reality, we know that this is an assembly, because we have the jaw, a separate part, we have the skull, also the teeth, which are separate parts. They should be separate also in our model tree. How we are going to ensure? By clicking separate all. And if you hover, you can see each part is separate. Now we can see the big skull. Let's name it for easier handling. Skull. And the top will be a simple jaw. I don't think that there is a multi-rename tool, but let's test it. Let's test it with Shift pressed, right click, rename. Let's see if it works. Now only for one file. It does not rename all the files. We are satisfied with this for the moment. So we were going to prove that, or let's make at least one part as a solid body. When you click here this checkbox, yes, you can somehow easily change its visibility. Now it's not visible, all the parts are invisible, all the parts are visible. This means that if we make all of them invisible or hide them, we can unhide, yes, only one part. Let's use only this jaw. You remember the plane that we just created. We will also make it visible or usable, let's say. When we click the plane, we can select the section mode in order to ensure that it is, yes, a shell, hollow body. We can return to 3D mode by clicking this green cube. So let's do the first conversion to solid. Right click, convert to solid, do not merge faces. It will give a warning regarding complexity, time, whatever. Are you sure? Yes. You can now see that from the original, let's say, Faceted body, which was hollow, now it is a solid. Maybe you ask yourself, how do we know it's a solid? Only because the icon changed? No. Let's go in section, again, click the plane, then section mode. You can now see the hatch here. This is a clear sign that the body is hollow. We can, is solid, I'm sorry. We can show all the parts again and clearly see the difference between the solid part and the other shell parts. Alright then, let's make, for the moment, let's make all the parts as solids. we can hide the solid one, select only the faceted parts. Right click, convert to solid, do not merge faces. The same warning about the complexity, and it will take time. We're happy that we now have a full model with solids and everything looks correctly regarding the model tree and in a simple overview. Alright, let's hide the plane a little, or maybe let's ensure that in section view they all are solids. You can see them with different hatches. Yes. On the first view we can see that the tooth, this tooth for example, does not collide correctly with this upper jaw, because it's not, we need like a Boolean operation, a cutout, for the tooth to make its own cavity inside this bone. We will ensure that operation in the next steps. So here we cannot clearly see what occurs. We will just move the section plane a little. It's very easy to move it. We will click here, then move in order to touch or to enclose, also to intersect other parts. Okay, so now it should intersect the lower jaw, the upper jaw or the skull, also the upper and lower teeth. The plane is selected. This means that we can click the section mode button and click here the plane view button for a very easy assessment. You can see the same problem. There is no correct Boolean operation between this lower tooth and the jaw. Also, there is a collision between these two teeth. Also, the upper tooth collides with the upper jaw. With the skull. Let's do our best to correct all of these, because base principle, axiomatic principle, states that two bodies should not occupy the same space at the same time. This is a golden rule. We should ensure this in our 3D models when and before performing simulations. We can take a look inside also, yes, and see that the teeth do not, let's say, do not touch correctly. We will meditate on this, because to ensure some Boolean operations between these two teeth in exactly this same position means that we will need to chip or to cut out from one of the teeth. I'm talking about this pair, for example. Also in this pair there is a collision. You can see this face that intersects abnormally the other faces. Also this face. We can exit the section mode by clicking the green cube. Let's hide the section plane a little while and look here what occurs here. Yes, we can see collision between the teeth. If we leave these bodies to intersect one another, we will surely have problems further in the simulation. We can see here also abnormal intersection. Take a good few minutes to assess your 3D model prior to using it in your FEA and further modeling, because in such a way, with this brief inspection, you will make an overall, hopefully good idea about what is to be done with your 3D model in order to achieve a good timing for the modeling than for FEA. Alright, because we can see that the skull and the entire assembly is somehow symmetrical, let's work with half of the model, because once because we will have half of the parts in principle, then we will cut the duration of the modeling in half. It's just normal to do something like this. So when we are going to cut, we see here that let's create a plane exactly following these edges. We will just select these edges and click the plane button and see what occurs. Look, exactly a plane made exactly on the middle. This means that the previous plane, which was somehow skewed and pretty random, we will just delete it because we have a very nice plane here. We're good with the lower teeth, let's say, regarding the symmetry. We're not good here. You can see that it intersects one of the teeth, namely this teeth. Okay, so let's just delete these teeth. For easier selection, you can triple click the solid part, 1, 2, 3, or for not easier selection, you can just go to locate a structure tree. So choose the part, right click, locate a structure tree. Yes. So let's do also the hard part, and it will show it here. Yes, this is the culprit. So triple click, just hit the delete button, and we have now perfect symmetry. For what? Perfect symmetry for what? As you remember, for cutting the entire model in half. So we have the command split body. Remember to always read the tooltips, yes, to understand what it does. Split body. It says either up or down. Click a target object, of course auto-saving, why not? Click a target object, box select, or click the select tool guide to choose multiple, whatever. We're going to cut this. Also with control pressed, you select this part. We don't need to select the teeth because we are exactly in the middle of the teeth, let's say, somehow. If you click these small bumps, the small hemispheres, you obtain a plane view on exactly normal to that axis. Here we are normal to the y-axis. If we click on this arrow, where we will be normal to the x face, we will be normal here to the z face. Alright, let's come back to y. And somehow it's not oriented correctly, it's horizontal. Remember that you can rotate, yes? If you hover here, you'll have such a circle, and you can rotate the coordinate system in order to obtain a logical view, let's say. Alright, so we selected the bodies. Now it says click a face, plane, or an edge loop to use as a cutter. We will click the plane that we just created, yes? Click the plane. The control button is released now. We are free to move. We will just click the plane. and you can see in a while that the parts will be cut. So you see, when we hover, we can see the cut parts. It says also click regions to remove. Let's click this part, also this part. These we cannot click because we didn't select the teeth. We only selected the skull and the jaw. Alright, the command finished. This means that we can hit escape to exit the command. Hit escape a few times. What we see here is that the skull is filled. Alright, we need to remember that the skull is filled later on. It's solid inside, it should be somehow hollow to make space for the brain. Let's select all the teeth that we don't need. The easiest selection is from the right side to the left because it's very inclusive. Hit delete. It says fail to remove faces because when we selected as previously, we also selected some faces, not only solids. Yes. So let's select, for example, something like this. It will give the same warning regarding faces because we didn't select a full solid body here. Nevertheless, we can just triple click and hit the delete button again. And this way we have a reliable half model. Alright, let's go to save here. And choose here maybe episode 1v1 skull teeth jaw. Let's put the first version in the end. A very good hint for you is, remember always, in order to have an independent scdoc space claim document, I will remind you, yes, space claim document, in order to have a version or a file that does not depend on other versions, you can always right click, choose source, internalize all. Yes. It will ensure that you have a standalone file not dependent on other versions. We will do it even though we don't have other versions, but we will do it just to be safe. If you click save, it will save upon this file. Just save, saving design. Alright. I think we can hide the plane because we can even delete it because we have this face materialized very well. Let's see what we need to do here. We need to resolve these collisions. We will ignore the fact that the teeth do not, let's say, they do not touch very well for the moment. So let's go to editing. We advise you to remember this command, prepare interference. Even though we assessed visually some of the collisions, the interference button will be the absolute teller and objective assessor for our collisions. It takes a little time because of the many facets of this model. And you have seen, I think, either stereolithography files, STL files, or OBJ, or many other files. They usually use these facets, or with quadrilateral faces. Here we have triangular, but also quadrilateral faces are possible, or quads. So what we have, some collisions between the teeth and the lower jaw. We will not care in this episode about the roots of the teeth. The correctness of the anatomical model is not the purpose on this episode. We are just going to make this file or this model usable for mesh and simulation. Also, we haven't a touching and collision between the teeth, and we need to understand what is optimum to do. Because usually the teeth are somehow buried inside the skull and in the jaw, we will choose for the teeth to penetrate the jaw and not the other way, because we can intersect also the other way, and we will somehow have half of the teeth, yes, without any roots. For this moment, let's just hit this complete and see what occurs when we do this automatic command, this default option. Remember that we will also maybe use the subtract from smaller body option, yes? Now we are going to subtract from the bigger body, because SpaceClaim calculates the volumes, and I expect here the tooth to remain full, yeah, and the skull to be cut out because by the tooth. Also for the rest of the teeth, because the skull is the bigger body. Also here the jaw is the bigger body. We expect by default this cutout operation that will occur to be very successful. Let's see what occurs here. Regarding these intersections, because at this moment we don't know which tooth is bigger than which tooth, and we will visually assess if the model is correct here. So it takes some time because of the number of triangles. Fixed, so we should be happy now. Look, there are no interfering bodies anymore. And let's hit escape to exit the command. Let's see what occurred here. The model looks very nice now. You can see that those collisions were solved now, yes. And look here how correctly enters. Just for information, let's triple click and see if the tooth is buried in the skull, and yes, success, the tooth is buried in the skull, as it should be. Of course, in this model the roots are not clearly visible, they are not modeled at all, but we do not care for the moment. We are doing some basic modeling, so we should not care for the roots. So the same occurs for the other teeth. Let's right click and hide this tooth to see, yes, to see the cavity that it created inside. Let's triple click here. You see, it left some of the intersecting body, yes. The common body was left inside, let's say. What we can do here very easily is to hide all the teeth. Very easy is to go so we know that this is the jaw. Let's rename it. It lost its name. This is the skull. Let's hide them. The tooth, the jaw, also the teeth. One tooth, second tooth, third, and so on. We do this manually because we suspect that some portions are left inside the model when the cutout was made. So there is no portion, which is very nice. Let's hide the plane. I was under the impression that I had some additional parts. Let's hide this. Yes, you can see here there is an additional portion. Oh, no, only the faces were separate. So when you double click, you can select a chain of faces, so the neighboring faces will be selected together when you just double click. But when you triple click, you will select the solid that contains those faces. This means that we do not have additional solids. Yes, only we have some faces that are united. But in reality, look, if we triple click the skull, right click hide, we do not see additional parts or chips resulting from the cutout that we just made. Alright, let's see here what occurred. I will hide this tooth, and you see this tooth is somehow chipped, and yeah, it's not very nice, to say the least. Let's move this plane in the top, auto-saving now. It stays in the way. Can I move it on the top? Of course not. Usually planes are the last to in the list from the model tree. Alright, we had bigger collisions here. Yeah, we can see that the teeth are very heavily cut here. We'll think of methods to repair these teeth in the model. So we do not have collisions anymore. What I think is worth doing, let's create two assemblies. The jaw with the lower teeth and the skull with the upper teeth. Alright? So for this let's select the skull and hide it, because in this manner we can also it's not so easy, but let's do it. So now I'm hiding the upper teeth. Let's create an assembly of all these. Yes, we will select all of them. You can see some of them highlighted here. Look, jaw there, and yes, we can right click, move to new component. everyone, not each. All of them move to new component, which is in reality a sub-assembly, let's say. So here we will name it like lower, and what remains, of course, are these. We will not complicate the selection, just with shift pressed, right click, move to new component. Of course the name will be upper. Now you can see that, for example, we can hide them by sub-assemblies, which is very nice. Why I separated them into sub-assemblies? Because I would like to open the jaw. So the jaw with the teeth is in the lower sub-assembly. We can go now to design and press the move button, and in the somehow in the center of gravity of the entire, or in the mass center of the entire sub-assembly, we will have a such coordinate system. Yes, and personally I would move it around here, which is a point from which this assembly will rotate in reality. Let's just rotate it now to see what occurs and how natural it feels. You see, it does not rotate extremely correctly, but it is a beginning. We will undo this operation. Let's save the assembly because we are satisfied by now. So, as I said before, we can select a new coordinate system, let's say, as a reference for the movement. Our problem is that for the moment we do not have a decent, let's say, axis here, a decent rotation axis materialized here. Let's see how to make it. Yes, there is this option. I selected the plane. Let's go to the sketching mode. Let's just create a construction line, something random because we will move it afterwards. Return to 3D mode. So now we have this line. What we have to do now is to rotate it about the y-axis. In order to understand what I did, it's something like this. Let's go here to watch it from the front. We will select the line that was just created in the sketch and hit the move. Yes, let's now rotate it. The coordinate system will be made in the middle of the construction line. Let's rotate it, and we have it here. Let's look on this side. So the line is here, but we would like to make it, let's say, around here. Yes, so this means that I think we can move it manually. What is nice in this when using my biomechanical models with irregular geometry, yes, not regular geometry, is that we don't need to be extremely precise, which is a very nice advantage when working with complex models. So we have now the axis for to rotate the lower subassembly. Yes, I will remember you, or I will remind you about this. This is the axis. It's seen as a point from this axis. from this view, but when we go here, we can see it, yes. So this is the construction line. Let's go again here, and in order to, yes, this is the construction line. Alright, so let's move this assembly. Yes, I selected it. Let's press the anchor button. Then as a reference, we will click, or we will select the line, the construction line that we just moved. You can see now, it's not easily visible, but we'll make it normal, planar view. You can see now that the rotation center, the reference for rotation, moved to or on the construction line that we just created. Let's rotate a little and see if it's more natural. Look, it's more natural now, and it looks very nice. 3, 5, 4. Let's make 350 to have a round number. I will write it down. We need to remind this. So we only rotated with 10 degrees, yes? Because the full is 360. Alright, so we can now somehow edit these parts. We see that this, for example, this tooth is badly damaged. How can we fill this? It's not so easy, let's say. I will show you the options, if there are any. I will hide other parts and focus only on this tooth. Let's just select these faces. Yes, you can see that we have this crater, this depression, this cavity selected. Now with Ctrl pressed, we can unselect or deselect the unwanted faces with Ctrl pressed. Click everything that's orange and does not pertain, or it's not inside the cavity. Yes, there is some effort to be put in this modeling, but if you have the patience, you have the possibility of doing some awesome work. Yes, with the middle, with the mouse scroll, you can rotate the model. Let's hit delete and see what occurs. Yes, look, it's nice. I would say it's nice. I would keep it. So let's move on. Oh, which one was? Who knows? So this one. Yes. Let's go to the next tooth that is badly chipped. We do not see. There is some chipping between these teeth. Yes. Also here, but I don't know. I don't think they're not unusable. Okay, we can use them. Let's see here what occurs. Okay, it looks nicer. Do we need the construction line? Yes, we need it for rotation. Let's hide it. Let's hide the plane. Let's hide the upper side because we don't work with it. Here I wanted to maybe to check these parts a little to see how they're. No, everything is fine here. Click once, it hides. Click once, it shows. Alright. I can click also here to ensure. You see there is some chipping here, but sincerely I will not waste more time here because we need more time. On the other side, you can see here a crater. This means that it collided with the upper teeth. Let's do the same as we did before. I think it's easiest now if we click them with Control pressed. When you select such thing as an edge, yes, just with Control you can unselect it again. Remember to have lots of patience and to rewatch this episode, because we have the tendency to work with a higher speed. Let's hit the delete button because the crater seems selected. Try to remove faces. It's a problem with the here with the, let's say, the neighboring faces. With there is an abrupt passing from this face to this face. What should we do? Maybe let's also select these. No, I just panicked. We have here these two small faces that we forgot. Let's click the delete button. Failed to remove. Did we forget? Did I forget something? Let's see. Here. So, yes, zoom in very much, very often. Delete. Yeah, let's be more generous with the selection. Select some adjacent neighboring faces. Maybe also these two. Also this one. Let's click delete again. I think it's time to just let it go. Yes, let's not tire ourselves over this matter for the moment. We will assume that the lower is made. Let's go for the upper. Now, in order to preserve a good backup, let's say, we will save as V2. Cancel. I will do again the source internalize all things. Alright, file, save as V2. And this will not depend on V1. Look here, V2. If it got out of the screen, yes, well, we need to tell you that we're using only a portion of the display, and some things may be out of the screen. There is some chipping here. It's so obvious. Let's solve it, or let's do our best to solve it. Hide others. Easier selection. Alright. Let's hope that everything went nice. Also here. Remember to not despair and just repeat things again and again, and you will succeed. That's for sure. Let's unselect what we don't need, what is not part of the cavity. This is not part of the cavity. Delete. Same problem again. I think we have some faces, some hidden faces here. There is also this method, you can remember it, just keep it in mind. You can select a face, right click, detach. This will mean that it will create like a shell body. Yes, you see now it's transparent, and we have, this is a shell body, it's not a solid anymore, you can see it here. Yes, so that triangle is detached from the rest of the tooth, which is shell body now. Why I did this? Because we will ease, let's say, in a easier way, we will select this depression now, and we will delete those faces easier. Alright. Let's unselect what we do not need. So, if we hit the delete button, a big cavity or hole will occur. You can see it. That initial triangle just disappeared because it was in the cavity. Now what is left for us to do is go to the repair tool, and what we have here is a missing face. Let's click the missing faces. Look here, it says that it finds an area. Let's just click the complete and fix the face and see what occurs. See, the 3D model is now correctly done and the cavity is filled. Yes, it's for this episode, it's we will leave it like this. We do not need the lower. Let's go for the other teeth that are badly damaged. This is badly damaged. Hide others. We will yes, we will attempt the default selection. Just for fun, let's see if it finds the cavity. Right click, select depression, and it somehow selected the cavity, which is pretty neat. Let's help the selection with these faces with Ctrl pressed. Should we select also this one? Why not? Now let's press the delete button. Of course, why should it? Why should it work? Yes. Again, the same method, detach. Let's see if the depression works anymore. Yes, it works. Let's select also that face. This is the cavity. You need to pay very, very, very much attention, very close attention when selecting these faces. I'm doing it fast because I have some experience. Let's delete these faces. We have a cavity and we're going to solve it with the missing faces. Found one area, just click it and it attempts to fill it, and for this moment we will accept it. The cavity is full now, or is filled. Alright, here is a very, very big cavity. I wanted to hit hide others. Let's go for select depression and see what we can select. Nothing very useful. I pressed Ctrl and go for the depressions. does not exist anymore. So this means I think we should edit it manually. Let's fastly and quickly solve this because it's very easy. We have a chipping here. Everything that I'm doing here is from the mouse scroll, so just test it. And of course the easier things do not work as fast as anticipated, of course. Why should they? Let's do the detach thing again. We will select the depression again. Just hit delete. We go to repair missing faces. Look, the hole is filled. We will accept it. Let's hit the save button. Now, regarding this big cavity, it's a lot of work here. I was wondering if we should maybe cut it on this diagonal and mirror it. Should we or should we not? Let's see. Let's see if we why not. We will create a plane here. Yes, and let's look on top and somehow position the plane to achieve this diagonal between or along these two peaks. We should somehow unite these two mounts from here. So first time we will move it somehow like this, and we need to rotate a little the tooth. I don't know if it's a good idea, but let's see what occurs. Do we have an alignment? Alright. You know what? Give or take. Let's split the tooth according to this plane, yes. Click a target object, this is the target, and click a face plane, whatever. I split it. I will remove the portion with the big cavity. Now let's mirror what we have here, yes. I will hide the plane. Let's mirror what we have here. We have the mirror command. Select mirror plane. This is the face. It's also a plane. We can also select this plane, but we will use this plane. When we click the part, you can see that we can. Yes. Oh, and it looks surprisingly good. I think I will keep it because it looks too nice. Nevertheless, we'll have to deal with this cavity now. We created another problem. Let's see if we can solve it. If not, what we need to do is delete this cavity from the gum, let's say, or from the jawbone. So select depression. It selected something. I don't want to get my hopes very high. Let's just select all of them in order to make sure that we did our best and we tried everything. Also remember that patience is key. If you have the possibility, you can fast forward the movie for, I don't know, maybe 2 minutes, 3, because it may seem boring for some of you. Now I selected an edge. Let's go and unselect it. Everything is done with Control pressed, of course. Let's unselect it. We need to select every nook and cranny. Now, when performing such operation, you will understand why these type of geometries, I'm talking about organs or biomechanical parts, are not often used or simulated by people. At least they are not shown on YouTube, except I'm not bragging here, but on expertfea.com and afem.bio, because we have experience with such modeling, we present, offer and show simulations using such complex geometries with initial faults, collisions and errors. So we need a little more patience. Remember to keep the control pressed, otherwise we need to do it from the beginning, to repeat the operation. We somehow selected everything, but we should not get our hopes very high. We'll just keep our calm and cool. Let's hit the delete button. And hope for the best. So this is a domain that requires very much attention, very much patience, but the rewards are very, very big. Once we solve the model and the FEA, all the effort is forgotten, and we're happy with what we obtain. Feel free to fast forward for a while. Let's hope that the software will give a sign, and sometimes it has the habit of either staying like this for hours or just blocking itself or freezing. So let's hope we're luckier than this. The other method would be as we did before, to detach them, yeah, as we did before, and repair the missing face again. But yeah, let's see what occurs now. Look, failed to remove faces. This is a good sign. At least it didn't froze or blocked. Let's save again. Yeah, they are selected. Let's go to detach. Face against first face visibility. Interesting. Let's see what occurs. Oh, we forgot the face. Yeah, nobody's perfect. Maybe we may be sometimes too tired and forget some faces. I hit the delete button again. So, as I said before, working with biomechanical models with such irregular shapes can prove to be difficult, but as the old motto said and says, that quitters never win and winners never quit. We should never quit, we should never give up, because we don't know where is the end. The end can be after one more click, after one more minute, so we should always strive to achieve the end, whatever it might be, in order to then use it either as an example that it didn't work, or as a positive example that it worked. Sorry for the filler words. I'm doing my best not to bore you with this long wait. I think I will cut the video. Oh, no, let's not cut it. So we need to detach the model, yes? The faces. Let's detach them. Did it keep? It would be nice if it would keep the selection of the faces. Yeah, the skull model is so big that it takes a while to even detach the faces. We will cut some of these long waiting periods. Basically, what we're aiming here and wishing for the software not to freeze. It's advisable when doing such operations not to hit the stop button, because usually the stop button will freeze the program and make it crash, and we don't know what version was saved by auto-saving or what we saved in the past. It takes a while because it needs to create at least two shell bodies, one big shell body with the entire skull and almost entire skull, and one small shell body with this cavity. This is why it takes so long. We cannot blame it on the CPU or the RAM, because we have enough. For a little flexing, let's see how much RAM we have. So yes, so we have yeah, the RAM is 64 gigabytes, and the CPU with 64 physical cores, so yes, we should not blame it on the hardware capabilities. Oh, good sign is the fact that it kept the selection. This means that we can now easily click the delete button, and we have a very easy selection now. Let's go to repair missing faces. Yes, this is the missing face. We will somehow fill it as we can. Or let the software fill it. So this is the filling of the cavity. You know what? Even though it does not look nice, we can pretend it's an inflammation. I think things will look better when the respective tooth will be there. Yes, let's show it, and we will do the combine operation here. So let's go to, I will save this version. We will hit escape to exit the command. We go to design, we have combine here. And let's read, click a target object, we want to cut the skull. Click the cutter, and the cutter will be the tooth. The tooth will make its way in the bone and in the gun. Alright, let's hit escape now. I will hide the tooth in order to see if the cavity is properly created. You see? We have something remaining here. What's remaining? The cutout didn't work. The operation didn't work. So where is this is the tooth? It could not make the cutout. Or maybe only for this part, maybe we should subtract the other way. Let's see what occurs. Click a target object. use the tooth to be cut. The cutter will be the skull. Let's see for fun what happens, what occurs. Yes, there is a problem with the intersection. This very complex shape, yeah, the newly created surface cannot somehow cut the tooth because there are also these collisions. Another method for cutting we have, you remember the prepare interference. Let's see if the software, you see, there are no interfering bodies. Let's see in section what occurs here. We will make a plane here, hit escape, design plane. I selected this face. We will rotate this plane in order to see. We'll do something like this, then move. I want to fully capture the mound, yes, this mound, and the tooth, something like this. Then click the section mode. It looks correct. We have hedge here, hedge here. This means the combined operation, the interference, the cutout should work in theory, but this face is too complex. Let's hide the plane. What other method we have? We have this method, we have the split body method. So let's attempt to apply it here. This is the target. We want to, for now we want to cut the tooth with this complex face. Let's see if it's possible. It's not possible. Maybe just for the time we should follow the motto: if you cannot beat them, maybe it's time to join them. So should we join these two, or let's leave them for a while and think about. We'll think in the background what should we do there. Alright, let's somehow reposition the model again. We will rotate the lower component. Yes, we will rotate it about this construction line, which serves as a rotation axis. So let's do it the other way around. Of course it does not work. Hit escape. Move, click the subassembly, lower, click the anchor button, then click the construction line. Alright, the reference system moved here. Let's rotate. Come on, why don't you? So sometimes it needs a very sturdy selection, which we will do it like this. Move the anchor here. So let's attempt another rotation. Look here. So it looks nice and nice. As 5, let's hit 7 degrees. And yes, we're almost there. Maybe 8 degrees until they're close to touching each other. I'm talking about the subcomponents. It's too much. Instead of 8, maybe 7.5 degrees. Yes, it looks nicer now, even though it does not, let's say, sit very well. We'll pretend that the person is not, let's say, very healthy regarding the stomatological and dentistry side. Is it me, or this jaw does not fit correctly here? Maybe it's the cause why these teeth do not sit very well. Let's look a little on a site that I prefer. It's called human something. This is it. Is it goat body, whatever. And let's choose here the bones, the skeleton. Let's look on how the jaw is situated here. We will hide this. Yeah, come on, show me the jaw. Exactly the jaw that I need is not shown here. Yes. So we can see here that this side of the jaw is inside and it's here. Let's just move it a little. For the free version, we cannot orbit the model very well, but we can see, for example, that this goes into the cavity, and here it's not the case, it's out of the cavity. Let's somehow maybe move things around, just a little. Here it sits very well. Also this thing has a cavity here. We do not have a cavity for this thing here. This means that I think the jaw is from another part. From another model, and was just imported here and assembled. So the lower teeth are inside the upper teeth. Yes, we have the same. The lower teeth are inside the upper teeth. Let's just move this thing a little out. Yes. Did we begin to have collisions? Not yet. And we need to move the jaw. Maybe something like this. also like this. We will also, let's hit internalize all, source internalize all, file, save as, version 3. So now we should not have, it created a crater here, this bone. It looks nice now. Yeah, this part is not from this skull, but yes, we will make do with, we'll use what we have. Let's get rid of this cavity just for fun. Select depression. Let's see if we can get rid of it. Yes, press the delete button and hope for the best. Ooh. Oh, miracles occur. Alright. So, I'm hoping to align them even better. There is too much gap here. Are they inside there? I'm not inside now. Alright. Let's go for the lower. What should I move? Let's leave it like this and make a decision regarding these two parts. What should we do here? Let's hide the tooth. What I remember is that this tooth, come on, this tooth was made with the mirror command. This means, I think, maybe because of the mirror command, you can see if you hover, you have some points, small points. This means on the mirrored plane. There was a plane here. Do you remember? I think this plane. Yes. And when you select a face, no, this is a section plane. Let's see if we have a mirror plane. Do we have? Yes, this is the plane for the mirror of the tooth. When we select a face on this side, yes, you see it also on the other side, and mirror is selected. This means that the mirror command blocks any combine or separation of the bodies or any intersection because of the mirror command. Let's go and somehow get rid of the mirror command. Right click, we were aiming to have something like make independent. We're looking for something like make independent, but it's not available here. If we go to detach all, what happens? It makes it with faces. All right. Hide others. So we have these faces. Do we still have the mirror? Yes, we have the mirror. Let's go to repair. Stitch. Do we have a stitch? Yes, we have a stitch. Let's see what occurs when using the stitch command. Yes, this is the model, but is the mirror present or not? Let's see. Yes, it's present, which is not nice. Not nice. Let's attempt the combine again. No. We can do something like this, I think. Let's select it. We go to New Design. Yes, let's go back. I just pressed Ctrl+C, but you can press Copy. You go to a New Design, and here you press Paste. You have it here. Is the mirror in place? No, the mirror does not exist anymore. You see, it does not exist anymore. For the moment, let's hide it. And let's copy this thing to the original assembly, because it should have lost the mirror condition. Copy paste, yes, Ctrl+C, Ctrl+V, or you can paste it from here. I think we got rid of the mirror, yes, so we have no mirror command anymore. Where is the? Here. Let's drop it to the upper assembly here. This is the new tooth. Now let's attempt the combine or repair. Let's go with combine for now. I'll click a target object. This is the target, and click the cutter. This is the cutter. Nice idea, but it didn't work. Let's go to prepare interference. No areas found. Alright. Split body, click a target, we'll split with this face. It's hard to split because it has multiple intersections and collisions. Alright. Yes, for this case, we'll just combine them and maybe let's attempt this thing again. Let's leave only the skull. We will copy it. We will also move it on the other new part, on the other file, let's say, in order to lose any dependency or inappropriate links and connections it had in this assembly. So it's a lot to copy. We will take a look at the number of facets or the triangles in the next minutes, just to see how many triangles make the software behave so slow. Come on. Let's just hide this. copy command. I didn't. I'm not modifying the topology of the geometry. Come on, space clean, come on. So I will stop for a while. Or maybe not. I do not care about this. Let's hit paste and see what occurs. So the part got imported finally. What I want to do is for the skull to lose its dependencies. Let's just click a little and hit the delete button. If we hit escape very quick, we can terminate the command. If we let the command for 10-20 more seconds, we cannot stop it anymore. So let's copy it again on the other side. Copy here and paste here. Oh. I'll pause the movie. So it was copied. Let's go to paste. Firstly, we need to delete this part. Just delete button. The skull should disappear. And we hit the paste button. And now we'll wait. So the paste operation worked. Let's move the skull back to the upper subassembly. We will show, yes, let's show, and we'll attempt to combine them again. We will need to cut the skull using the tooth. Of course it does not work. Let's attempt something like cutting a little of this inflammation. Do we have a decent plane? This is a decent plane. Let's go on the sketch mode. We hit the plane view and we will somehow follow the contour of this inflammation. We'll use a spline. Let's use a spline to be as accurate as we can. and only dream of accuracy. We have an intersection here. Yes, it looks nice. Oh, ooh, I like the spline command more and more. Should I use it again? Let's use it again. From here to here. Right. We have a finished spline. We have a closed contour. Let's return to 3D mode. And we will just push this thing over. I selected it and we're in the pull command. If we go here, we should see the properties of the pull command here, but yeah, let's not stress on this very much. They should show here the properties. Here on the options. Let's go with cut. On our options we have something like cut, and yes, we will just drag it here, something like this. Yes, there is a cut. Now let's attempt the combine operation again. We don't need a plane, we have this tooth, we will show it. So this is the target, we want to be cut by the tooth. Yes, we want, but the software does not want. I don't like this thing. Let's move the tooth a little bit, just a little bit, on this direction. Yeah, to have a clear collision. Okay, something like this. Let's combine again. This is the target, this is the cut. Oh, this was the option. This means that we can go back to the inflammation. This was, I should have moved the tooth. Let's go before all these things. Control Z or undo. Here is the undo button. We will show the tooth again, because yeah, this the multiple intersection was the cause here for yeah, and now it's solved. We have only a clear intersection. So this face did not protrude it through other faces. So now it's a clear. It's a clear intersection now. Yes, of course. Why should it work so easily? Let's move this maybe here too. Something like this. Yeah, something like this. Or maybe put it entirely on this round face. Yes, this looks very nice. And we have a clear one face intersection. Let's see, maybe we're lucky. Combine. Yes, you see, with persistence we achieve success. This portion that should not exist, should be a cavity, we need to delete it, to remove it manually. Let's say triple click, and here is our cavity, which, yeah, it's a cavity. Let's show this thing. Yes, so now it's everything is fine. Let's say we will show all bodies and save this model. Just for fun, let's look a little at this intersection between those two teeth, between this problematic tooth and we have a little intersection here. I was not expecting this intersection. What's happening? What? This tooth should be deleted because I used this tooth. This is the proper tooth. Yes. Now this is the plane, the section plane, and we will use it to look on the intersection. Section mode, and yeah, let's look inside. Look how nice it looks. Yeah, let's even rotate the plane a little in order to check also the other teeth. Let's say it's not very nice, but yeah, something like this. And we're looking. We want to cover more and more teeth. Yeah, something like this. Let's hit the section mode button and we will look inside. Show all. Yes, you see now there is no collision, no intersection, and everything looks nice, except the fact that, as I said in the beginning, we don't have the roots of the teeth. So we somehow, I can say that the model is pretty correct now. Yeah, let's save it because the next one will be the full model. So we will use this face as the mirror face. Before doing this, let's check for interference. Always check for interferences. Always check for interferences before doing complex, other complex steps and important commands. Yeah, many facets, many calculations and computations for the computer, so we worked very clean, let's say. Let's say, escape. Let's, yeah, we will save it with another version. Source internalize all, file, save as version 4. And we will say something like, here we'll say something like full caps lock, because we will mirror everything. So mirror command, select mirror plane, this is the mirror plane, and with the window we will select everything. It takes a while because, yes, in the facets. Now we will double the number, because until now we worked only with half of the model. for we have we will need to do two things here. So these two teeth were, let's say, joined together. We need to separate them. This is very easy, and we will need to approach this jaw, these two halves, one to another. Let's check the gap. We'll select one face, then the other face with control pressed, and we have the distance, 7 millimeters. It's big. It's a big distance. 7.18. I will write it down because we will approach with half of this. Yes. Yes. 7.18 over 2 equals 3.59. We will need to approach them with 3.59 on the both sides. Alright, let's make the separation with these two teeth. We'll hide others. Yes. It's very easy to use this plane. Split body. This is the body and this is the plane. So we have two separate parts now. Yes, it works in mirror, and it's so this is separate from the other. We are good on this side. Let's approach these two, but we will keep in mind that we might have a collision here. We might have a collision when we move the entire jaw with 3.59. So I triple clicked. Why should it work? Now these sub-assemblies are not very correct because of the mirror command. Oh, it did something. For fun, let's select upper and see what occurs there. Here is lower. Maybe it's correct. Alright, so we will select, we don't care about the upper now, let's work with lower. Let's select only half. It's very nice mirrored here. Come on. Yes, because of so many facets, the software tends to freeze. So this is the right half. I selected the right half with the shift pressed. Lots of patience. we'll move one half towards the other, but not exactly with 3.59. We will move with 3.55 and leave a gap. So let's see how we do it. I chose to look normally on the y-axis. This is perfectly normal view, let's say. And we will go on the x-axis with, I said 3.55. I just bring something like this and write by hand. I will write by hand 3.55. Hopefully it will not join the parts now of the two halves. Hopefully it didn't join. Let's write 3.55 and we should have a small gap there. As mentioned, yes, there is a small gap. Why is this small gap? Because what I want to do is to remove it somehow. How is easier? Let's hide the teeth. We'll show only the jaw parts. Let's look from above. I want to do a very good zoom on the gap for a better selection. You see the gap, and let's just select it from the left to the right, not from the right to the left. If we select from the right to the left, we will select too many faces. We want to select only the faces, the lateral faces from the gap. You see, if we zoom in, we selected these two faces. Yes. If we hit the delete button, let's see what occurs. Yes. Nothing occurred. Alright then, let's we have this method. We'll select this face or one of the faces and pull it towards the other face. Yes, we have here the up to. We click this up to and select the other face. This is the face. Hopefully they will join there. Yes, because of the mirror condition, it didn't do the command. Let's see if we can cancel the mirror condition. Can we cancel the mirror condition? Okay, we know that the gap is 0.08. Let's move one of the parts with half, 0.04, yes? So, so you can see when we have, let's say, lateral mirror, we can see a selection in the mirror, but it's not the same case here on the other axis. When we select this face, it does not select the other face which is mirrored. It's good to have in mind. What I said is something like this. I will move maybe this part towards the other part with 0.04 on the x-axis, and hopefully they will magically join. It's a simple selection, I didn't hit any command. For fun, let's close this model that we do not care now. I will hit the save button. So the right half is selected because it's orange. Let's move it on the x-axis with just a little to the left. Oh, exactly 0.04. Let's write down 0.04 just to be entirely sure that we don't have any subdivision in any micrometer or something. Yes, we're there. The parts are still separate. Let's look for a gap if we see a gap. There is no gap. Alright, so let's join them. I will look for a possibility to make the parts independent because I want to get rid of the mirroring condition. Can we make them independent? Not for the moment. We see that they are mirrored. Alright. Let's combine them. Let's see what occurs. If we want to join, the easiest option is to click one part, Control pressed, click the other part. And it does this command. So now they are joined because they have the same color. Triple click. Look, full part. Alright. So show all. Let's see if we have this collision here that I was talking about. We do not have a collision. So yes. 1, 2, 3. Do we have separate parts here? Separate teeth? Let's see. Yes, we have separate teeth, and this is good for flossing, you know, for the flossing thread. We are approaching the end of this video. Let's go to prepare and check for interference. What you need to keep in mind is that when we're taking this geometry to the FEA for meshing, we are obligated to do a tetrahedral meshing because of the triangles that exist on all the faces, and the triangles will impose only tetrahedrons on the mesh, or mostly tetrahedrons. Maybe some pyramids can appear too. So I will show just a small preview with how we can make the parts smoother and get rid of all these triangles. All these things in the next episode. This is just an introduction, the beginning. And yes, this is, let's say, the hard way, and as we progress, we will learn, let's say, the easier way and more elegant and more professional looking method to obtain a very nice face and without all these triangles, which they can look, let's say, nice, but they are not professional, let's say. Especially when dealing with explicit dynamics, all these small elements will count towards the solving time. The small mesh will make finer and finer time steps. Yes, it will and so will prolong the solving time very much. So we need to get rid of and maybe make the mesh more coarse. Also, if possible, the face is a lot smoother than what we see here. But these in the next episode, because as I said, this is an introduction and such modeling. Yes, we began with an OBJ file, and now we already have some solids. Yes, we have some interference. I don't know why. Let's just hit solve here, and let's hope for the best. Sometimes, and in certain areas, in certain parts, in certain conditions, we will need to choose which to intersect and to somehow to manually select the intersection and the resolving of the interference. But we had some luck with this model because the default operation worked pretty well until now, so we will use this. It's an introduction, and we should not keep the lesson too complex and too long with harder operations and harder, heavier approach, in order to keep the matters simple, as simple as possible. These two small bumps, yes, maybe the person suffered from an inflammation. Yeah, jokingly said. This is nice. I repeat the positive part of working with biomechanical models. We do not need the precision from the CAD modeling because every person is unique and there are tolerances. And for you engineers, mechanical engineers out there, you should know that the dimensions, the sizes, regarding, I don't know, distances, lengths, volumes, when we talk about organs and biomechanical parts, they are given in a range. I'm not talking about tolerance, I'm talking more about a range, so we should not be entirely and perfectly in need for absolute values. And we should have such relief because already the geometry is very complex, and we have many problems to solve in order to achieve a usable mesh, usable 3D model which can later be meshed in ANSYS Workbench. After this finishes, the next step we will just ensure a proper mesh in ANSYS Workbench. Hopefully we will not have errors, or hopefully we will not have many errors. Everything was fixed. We are blessed. This calls for a new version. Internalize all, right click, internalize all, source internalize all, file, save as version 5. Yes. So we don't have any interference now, or interference. We have this model. I said about counting the facets. Let's count them. Can I count them? When we select a faceted body before becoming a 3D model, it gives the count here, the number of facets. But now we are selecting a 3D model, and we will see if they will count the number of facets. I don't know if it will do this. So it doesn't count them, but we have this option of bringing this part again, the skull again, and counting the triangles here. You see, if we select all of them, yeah, they are not selected. Yeah, Control A or select all. Do we have select all here? Yes, select all. We can see here, yes, 80,000 facets. There, everything is counted also, inside and outside. We were here, version 5. Let's go to the meshing now. Yes. I'm sorry, I hit full screen, but it went on my display. Yes. Now I will open ANSYS Workbench while Space-Claim is closing. Let's see some challenges regarding the mesh. Let me resize the window. Alright, and here where I saved it on the ANSYS. Alright, let's go, for example, where on the static, let's go for the explicit dynamics for the moment. And here, let's import what we just made, show full version 5. You will maybe ask now, Claudio, why didn't you export as a step or parasolid or something. scdoc is the native file, native document. It's basically a document. This native file, let's say, is the most suitable, the best, because it's native to this pack. Let's save it as can we somehow copy the? Yeah, let's copy F2, Control C, F2, Control V, Enter, Control V, episode 1. All right. Let's double click. Now the mechanical window should open. I will resize it very soon. As fast as I can. For the moment it imports the geometry, and we know that the geometry is pretty big. Let's see how big is the geometry. Yes. Look here, yes. 115 megabytes, which is, we can say it's pretty big. So here you can see that it attaches the geometry. The mechanical window freezes when the attach is in progress. And maybe you'll ask, hey, where do we get the OBJ and STL files? We get them from such websites. CG Trader, for example. Yes, you can look for what geometry you need. Let's look for heart, for example. Yes, and we can buy them. Remember, they will be as shell bodies: OBJ, STL, FBX, C4D, 3DS, Max. You can see here, yes. 3DM, DAE, or maybe TurboSquid, the website that I also use. Heart. Yes, we have. Look here, from the most complex to the most to the least complex geometry. Of course, you can arrange them by price, even go for free, but you'll have very small. Yeah, it less complexity, let's say. And this is the meshing. These are hollow bodies, shell bodies. So the export, the import works, yes. So you can take such geometries and use them in your model. This is the easiest way. The hardest way is to obtain or to use computer tomograph slices and use specific software like, I don't know, maybe Magix or Mimics, or in order to convert the point cloud into OBJ or STL files. Then, when you have the OBJ and the STL, you can do what you have seen in this video. From converting from the initial facets to the entire 3D model. It detects a contact. I do not care for the contact right now, so let's stop. I will resize the window in just a second. All right. So this is the window. We were aiming for the mesh. Why I chose Explicit Dynamics? Because the elements are first order. So it looks nice. The different colors means that we have different parts, which is very nice. Let's hit save. It's a good habit to save very often. The first thing we should do when we have such complex geometry, firstly, we should choose virtual topology, because it will, when I unite some facets, and we have many facets, and it will heal some features. Let's choose behavior high here. Right click, generate virtual cells. It's a very good habit to use virtual topology when we have complex geometry with, I don't know if with possible errors, but which can produce errors in the future, meshing errors. So let's wait patiently. So it took too much time to wait, so I had to change the behavior to low, and let's hope. I had to interrupt the procedure. Let's hope that now we will have more success, I mean to have a smaller time, a smaller duration to generate the virtual cells. You can see as a preview, yes, that many faces were united, many facets were united in bigger, much bigger surfaces, which will create a quasar mesh, a thing that we need very much. Right, I will pause again here. So it was much faster with low behavior. Low means that it had, in the end, made a smaller number of virtual entities. With higher behavior, we usually have a bigger amount of faces. You can see now, yes, there is no facets now. No facet now. They are somehow joined in these surfaces, and yeah, it's very good. Very efficient for meshing, especially because in Explicit Dynamics meshing is crucial regarding the solving time. Let's attempt, we will suppress the contacts. Let's attempt Also meshing, we'll go to very coarse meshing, transition, fast. Maybe we'll use also some defeaturing, smoothing, low. Yes, let's save again, and yes, let's generate mesh. Can we use more cores? Let's put here, I don't know, 60. Let's generate mesh. So there is one part, the last part. It takes a lot of time. I think it's the skull, it's the biggest, yes. Whoa! We are blessed today with successful mesh. Let's see on statistics. 70,000 nodes, which is very, very, very good. Normally our lesson is finished for today because we have successful meshing. Just for fun, let's see how much will take for very simple solving. For interaction, because I suppressed the contacts, let's create such a body interaction. We will select bodies. Let's position everything like this, and yeah, yes, it's separate. Do we have a window here? Yes, box select, and I will select these parts only because I want them to be bonded. We go to body interaction, 15 bodies, they were selected already, and here we choose type bonded. So the teeth will be bonded inside the jaw, because I don't want to waste my time with, look here, how many, 51 contacts, and edit them and ensure whatever is there. This is the easiest way to ensure. Let's use something like a pinball radius. Maybe the scale is good. Let's see here. Yeah, it's pretty good. So let's use for maximum, I don't know, maybe 0.25 millimeter. We will not break the contacts. Let's do the same with the upper part. We can hide all these parts now. Right click, hide body, also this small tooth. Where is the skull? I want the skull. When we select from the right to left, it tends to select more than necessary. F9, we can press F9. Hide. Hide. Alright, let's do the same. We will create a body interaction for the upper jaw. 15 bodies. Bonded again 0.25. So we have short bodies, we have this one bonded, this one, and the default frictionless. What we want, just for fun, very fast, to define a rotational joint here. Body, ground, revolute. Let's select the entire jaw, hide all other bodies. Should we select the entire part, or yes, we'll go to faces. We have this thing here called extend to connection, which will extend the selection to all the faces. Apply here on the scope. I like the position of the Z axis, but of course we will need to move the coordinate system here to be here. Alright, so this joint received the coordinate system, and we would like to move it. Can we move it like this? Let's see, offset Y. On the Y-axis we'll go with, I don't know, maybe 150 millimeter. Yes. Maybe even more. Alright. And we need to bring it up on the... it's almost there. Let's offset also on X-axis with maybe 25. Yes, and it's kind of in the middle. The alignment of the Z-axis could have been better. Let's, if we can we align? Yes, we can align the Z-axis about the X-axis. The X-axis is perfectly normal to the view, you see? Z-axis is a little inclined, so here, principal axis Z, let's hit here global X-axis. Yeah, and after movement everything is perfect. You can see now we have a perfect point, let's say. This will be the rotation, let's say, reference or axis, the Z vector here for the entire jaw. What I want to do, I don't know if there is the time. Well, we want to clack a little, yeah, the jaw to go upwards, to rotate upwards in order to clank the teeth together. At least let's see the direction. Of course we lost the mesh, why not? We have update, we have update. Let's save first. It should be easier because it's only on the jaw, if I understood correctly. Yes. Yes. Let's assign maybe some smaller size. Let's see. The thickness of the tooth. 20 centimeters. This was a big fellow. Yeah, we should have scaled the model. By the way, we should have looked a little on the size, because this is a pretty big fellow. Let's say that he's a basketball player, a gigantic dude, or dudette. But yes, should keep in mind to scale the geometry. Let's see if we can decrease this number. By the way, because I care very much about this, I already saved the model. Let's make a duplicate, and we will not touch this thing. This is like a template. We will not touch it because we know that this is a good start once the mesh was correctly made. It takes a while because of all the geometry and the elements. The meshing also increases the size of the entire FEA. So the duplicate is made. Let's double click. Start in mechanical. We should put another material instead of steel for two reasons. First one is the most obvious. We're not simulating Iron Man. And the second one is the heavier the part, the longer the solving time, because of the Courant-Friedrichs Levy condition, I think. Yeah, it's related to Courant-Friedrichs Levy condition to mass scaling. So let's go and choose some polyethylene on the general materials. We'll assume this is a, plastic thing like the skeleton that we had in the classroom. We don't need at this time to have the real bone. I want to minimize this window, but it's not so easy. Alright, so let's save. I will select as material all parts to be made of polyethylene. Let's check the weight a little for the entire model. Properties, yes. Oh. Big dude. Yeah, he has the head of, my god, 700mm. Alright, we do not care at this moment. The geometry needs scaled, but our purpose was to make a meshable model, not to establish a good sizing now. Feel free to decrease to scale the model. Yeah, maybe with 0.3, 0.25. Not important for this lesson. Let's define the. We'll fix here for faster solving. Let's make the skull which has the most elements, the most nodes. Where is the skull? Can I see it? Ah, here, yes, this is the skull. When I go to statistics, it has half of the nodes. Alright. We have the possibility of making the skull as rigid, but before doing this, let's make a coarser mesh. So let's establish the scale of the tooth. 10 millimeters. Why not? Let's put here maybe 12. And and let's see what occurs. I'm not using the word happens, what happens, because I believe that nothing happens, nothing just happens. Things occur because of different reasons and causes, and nothing happens suddenly or out of the blue and without reason. No. This is my conviction. This is the skull again. Most time-consuming part. Let's see if the mesh is. Oh, we are placed again. And the mesh is the same. Not very good news. Where we patched, we have final mesh, but in general it looks acceptable, at least for the purpose of this lesson. Let's go here for maybe 21. We want to decrease from 65 to maybe 40,000 nodes. And yes, without any errors in meshing, because I presume some of the parts will give errors, I presume. This is chipped. We didn't solve this was S. That's for another time, or maybe you can cover it or solve it. 70,000 instead of 76. We're getting near something. So it's the time for 35, or let's leave here 25 and go for skull and jaw with 35. The default you see is 58. Oh, 58? The default? This means I can go to 75. Let's save again. Yes. It's a good opportunity, it's a good procedure to apply body sizing on some parts and see their default element size here, as we have seen now. It was 58, I was presuming around, I don't know, maybe 20 by default, 20 millimeters, but it was 58. Let's do the same also for the teeth to check their default element size. Yes, it takes some time because complexity of the geometry. This is where most of the people abandon and quit their work because it requires lots of patience and experience. We need to be creative and to find workarounds, new ideas. I think we are in a loop here. It does these. It makes these retries, 4 retries. Yes, I think the software wants to tell that it cannot do the mesh on the skull. Let's just stop it. Look, it made the mesh here. This means we will select here only the jaw. Let's leave it there. And here, instead of 55, let's make 75. Let's make, I don't know, maybe 63. Let's see also hide body. These are the teeth. So the default is what? Something is not right. Whatever. Let's go again with 63. Why not? We hit save. Let's hit save. Control S, save. It meshed to the jaw. Let's see now the skull. When purchasing geometry from these websites, you need to understand from the very beginning that it's not perfectly made, and after all, this is the purpose of this lesson and the purpose of the next videos, to repair what is here, because what you see is for show. Inside there are many collisions, many problems, open faces, and yes, we should not accuse the sellers for their geometries because they have no idea that the geometry will be used in a finite element simulation. They maybe haven't heard about solid meshing because they use only shell meshing as the habit in such 3D modeling. So yes, know from the beginning the fact that when purchasing such a model, the work, the real work begins in order to make it meshable as a solid mesh. In the near future, in the next weeks, we will implement a geometry page where we will sell the geometries that we used in our simulations separately with affordable and cheap prices on fem.bio and also on expertfea.com. On expertfea.com, given the fact that we have more than 300 models, we will group them in packages. We will have bearing packages, gears, 3D models. We will have I don't know, tools, 3D models, and building, let's say, or constructions, 3D model, etc. The skull is pretty stubborn, so how much we have now? 49. It's not looking extremely nice. I think we need to forget this thing and go to the beginning. We attempted something, yes. Sometimes it works, sometimes it doesn't work. Or, yeah, we can also attempt here, but it will take more and more time to decrease the mesh. So by default is 70,000 nodes. Instead of element size 25, what occurs if we make it maybe 55? Let's see. So we had 70,000 nodes. The hour of recording is 4 o'clock in the morning, so I started the lesson around maybe 3 hours ago. After midnight, and yes, it's more and more attention consuming. It's yes, nothing, no difference from the 70,000. Let's go with the default in order not to complicate things. By the way, before the default, I would like to test here. No, mesh featuring, yes. Let's attempt here something. This model, I admit, was not, let's say, practiced before. It's new for me, and I use it and I give the lesson like this because I wanted to say from the beginning how I judge and what you can do in order to make your FEA. I didn't, let's say, prepare the lesson. I'm judging in a raw manner, accurately, as I would think about this model. Look here. It's very, very nice. So we're on the very good direction. Instead of 70,000, we have 47. Just for fun, let's see here for the feature size. If I can hit here, I don't know, maybe 5 millimeter. Let's see what will occur here. Normally, some features smaller than 5 millimeters should be smooth, or they should somehow disappear. So let's see if it behaves as I anticipate, as I am anticipating. I think I exaggerated a little. 3. Let's see free what gives. You see some of the dimples and whatever, they somehow disappeared and they were smoothed out. Of course with some errors here. This is what I meant from the beginning. A measurable model without errors. 28. This is good. Only we need some finer mesh here. True. The teeth became a little crooked. We aim for something like 35 or maybe maximum 40,000 nodes. But yes, weak chances. There was also a pinch option. Pinch tolerance 0.5. I don't know. Let's test with 2 mm here. Generate mesh. So this is how I am approaching a new FEA and a new model. 47, yes, absolutely no difference. Let's do the same. I always tend to go to the default if the complications didn't bring any improvement. So I advise you to do the same in order to keep things simple. And when you make when you prescribe a feature, an item, a sizing, whatever, test them, if possible separately, in order to identify possible causes to easily isolate them. So let's save again. We will use this. As I said, let's fix the skull a little. We will select 1, 2, 3, 4 faces, then go to here to adjacent. 1, 2, 3, 4, 5. It's enough. Supports fixed. So we're fixing the skull and we're rotating the jaw here. Loads, joint load. Double click here. We have the revolute. The direction is not good, so we need to remember this. Rotation. Let's go here to tabular time. Yes. Let's define an end time for faster solving, 0.1 millisecond. Let's put here, and we'll let everything default here just for comparison. Why should you do something like this? It's not correct. Okay, all right. I said with minus. If I remember correctly, the rotation was 10 degrees, but yeah, I don't know, maybe 3 degrees or -5 to have a crush. Hey, I said minus. Yes, so this is the correct orientation, yes? From, yeah, upwards. Here, hopefully something will occur here. Let's insert some deformation and stress to see them real time. Control, switch to automatic mode in order to be updated in real time. Control S. Let's select the number of physical cores. In Explicit Dynamics you should always put the number of physical cores, and also what your license permits, and I am allowed only 8 cores. So this is the only situation when I cannot use the full 64 cores. Never mind. I want to see an end time, a solving time, firstly. Let's hope it will not be around 157 hours. In the end, I would like to make like a comparison before and after, and when I give information about this lesson, about these clips, I would like to show from the initial OBG file as a hollow shell file, and the something with stress and deformation solved in ANSYS Workbench, in order for the future customer, prospective buyer, to assess a little that he is taken from the very beginning to the proper and normal and yeah, to an useful end. I will pause a little. So it came back. Let's see the initial assessment. You should always look on the solver output to understand how the things are going. Yeah, there are some problems with a certain part. Can we see that part? Let's see it. Select mesh by ID, element. What? The problem is in the jaw. It looks like the jaw. Let's hide it. So let's see what the solving says. It seems like the case will give some problems. We forgot to record for a few minutes, and we restarted. I remade the solving with the normal and the expected parameters. So it says wrap-up timestamp controlled by a structured element. Let's see what is the element, the culprit element. We go here, right click, select mesh by ID, change to elements, Ctrl V, select. Yes. So this is a tooth. If you don't believe me, let's see it here. Yeah, meshing, the meshing of the teeth, it gives problems. I also remade. I suppressed this tooth and gave another error, meshing error on another tooth. Normally the meshing should be, of course, finer, but considering the fact that it should take 1 day, the solving, we don't have the time. Alright, I will give you some advice on these time steps. Let's take it slowly. Firstly, we'll make energy error 0. Maybe 1 e minus 8 second minimum time step. 1 e minus 9. 1 e minus 7 seconds. And here, scaling. Of course, we'll put 8, and that's all. These parameters should somehow be remembered. Yeah, it depends also on the end time. If we increase the end time, we can also increase these values. Increase means instead of 1 minus 8, we can put 1 minus 7 or 6. Alright, let's save again. We'll just hit one solve. Because of the coarse meshing on the teeth, I do not expect it to work. But at least we did our best. At this moment and for this lesson. So let's see what the software says. Oh, the solving started. This is very nice. It takes this amount of time. I can pause it and show you some results. Or we can even decrease more. Let's decrease this time solving by making the skull rigid. Let's make the skull rigid. I will duplicate this because it's a very good file and attempt the solving works. I will make a duplicate of this. Save. Or maybe even a jaw to make it rigid. When we make some of the parts rigid, because we don't care about the stresses and the strain. They speed up the solving very much. So let's do this. We can see some hills, plants, and something that looks like maybe a dawn or sunset. We don't know for sure. Alright, let's select the jaw and the skull. We will go to corresponding bodies in 3, skull and jaw, and here for the stiffness behavior we select rigid. Of course that we need to remake the mesh, why not? Update. The node count will remain the same. There is no change in the mesh. In the previous, in some older versions, it didn't need the mesh on the rigid bodies. But yes, in the last years it meshes also the rigid bodies. Alright, so we have the same 40 something, 48, it was 47. Save. We need to change the fixed support because in the past, you remember, it was put on some faces here, yes? And now we need to change it on the entire body. Yes, this is how you fix a rigid body. And rotation, I hope it goes like this, yes? Yes. I remember that you can alter and play with the mass scaling value. In order to obtain smaller solving time. Let's see if we decreased from 1.5 hours to something smaller, because we made two important parts rigid. Yes, we were right. So we will let it solve and hopefully see some teeth collide and show some stress and deformation. We'll pause it here and come back a little later when we have more percentage here, maybe 20-30%. Then we will see what occurs in the end. We need to frequently interrupt after we check here. Here is the plot is populated only after we hit the 5% mark. So now we don't have anything, but we go to fine. It's blue now, but when we exceed 5%, it should be populated right now. Yes. So it's it looks promising. It's starting to make something. So it looks nice. Let's see if we have some stress. Maybe here. Do we have some stress? Oh, here. All right. Let's put here 50. 50. Look here. It's very good. 25. Yes. It's even cuter. Yes, I'll be right back. So for the moment we're at 48%. Let's check the deformation. Yes, it's starting to hit the teeth. This will mean that we will have some serious crush. Look here, haha, it looks so nice. Oh, the things will aggravate because this skull is completely and entirely fixed. This will mean that we will have no deformation here, and some of the teeth are fixed like cantilevers, let's say, and we'll have some serious stress in the near future. Let's scope for 100 for the moment, maybe 70. Yeah. We will also publish this FEA. So we'll return. So the FEA just finished. We don't need to see these intermediate solutions. Let's go to total deformation. We will animate. We'll have at least 25 frames per second. So because of the high speed, there is this tremor that occurs. We will, yes, we will leave it like this. Let's hide the mesh for a smoother view. The stress, yeah, is a little high. Let's make it, I don't know, maybe 300. Yeah, so there is a maximum point here. I think this is the maximum. Yeah, around there, yes, we have a maximum. Maximum occurs in a certain tooth. We will not look in detail. This entire FEA will be available on the website. The 3D model, the final 3D model will be available on the website, on the fem.bio. The initial model will be available. So yes, we have nothing to worry. You can replicate, duplicate, and improve many times. such geometry, and yes, why not buy other geometry and see how you can improve them and what you can get out from them. So we will, with this that we successfully solved from a mere OBG shell hollow body to a fully solved FEA. Yes, primitive but working, and for an introductory lesson, this is really good and needs to be kept in mind. And yes, we will be waiting for you on the next lessons, because more and more advanced concepts will be presented, and more steps will be made to achieve more and more professional and more reliable results in a very efficient manner, with at least with in the beginning with smaller solving times. Then you can refine the mesh and increase the solving time according to your needs. Yes, stay tuned, and be sure to check us on the fem.bio. Let's show them again. explicit.com and fem.bio, and be sure that awesome things will be presented out of our experience of more than 20 years of being accustomed with ANSYS package. So best of luck, and have a nice day, and yes, believe in your bright future. All the best to you. Bye bye, and thank you for the purchase and for the support.